Hello and welcome to MyScience Tutorials. In today's video we are going to be looking at mole concept. Before we begin, if you are new to MyScience Tutorials, kindly consider subscribing and pressing that notification button so that you don't miss any of our latest tutorials on biology, chemistry, mathematics and physics. So let's begin. So we want to first of all start by knowing the definition of mole. So a mole of a substance is that amount of the substance that contains as so many elementary entities as there are in 12 grams of carbon-12. So what we mean by this is every substance contains some entities which we are calling the elementary entities, and then this number of entities has been determined or is known to us as the Avogadro's number or Avogadro's constant, given to us by L, which is equal to what? 6.02 times 10 raised to the power 23 entities. So it's either atoms or molecules or ions. Molecules or ions. It depends on the entities that we are considering in our definition. So if we say 1 mole of an atom, so we are saying that atom contains 6.02 times 10 raised to the power 23 atoms. If we are saying 1 mole of an ion, we mean it contains this number of what? Ions. That is what we mean by elementary entities. So the entities can either be atoms, molecules or ions. Now the relationship between the Avogadro's number, which is the L, and then the amount of substance or the mole represented by N. The mole is represented by N. So the relationship between them is given to us by what? Capital N is equal to small n multiplied by L, where capital N is what? The number of entities. Number of entities. Okay, our N is the mole. Okay, and then our L is the Avogadro's number. Avogadro's number or constant. So what we mean by this is let's just do a quick example. So if we say 1 mole of what? Of potassium K, what we mean by this is what? Potassium is what? An element. Okay, so it means what? This 1 mole of potassium contains what? 6.02 times 10 raised to the power 23 atoms of what? Potassium K. This is what we mean by what? 1 mole of K. So this is the number of what? Atoms of K that we can find in 1 mole of potassium. If we say 1 mole of what? Fluoride ion or fluorine ion, okay, what we mean by this is we have what? 6.02 times 10 raised to the power 23 what? Ions of what? Fluorine. This is what we mean by what? 1 mole of fluorine ion. The same way, if we have 1 mole of what? Oxygen, which is a molecule, we mean what? It contains 6.02 times 10 raised to the power what? 23 molecules what? Of what? Oxygen gas. So this is what we mean by what? 1 mole. So every mole of any substance contains the Avogadro's number or L, number of entities of that particular element. So this equation or this relation is very, very important. We can also find mole by using molar mass of a particular quantity. Now the molar mass of a particular quantity is the mass of 1 mole of that substance, and then the mole can also be given by what? Mass over what? Our molar mass. So this relation is also very, very important. Now let's look at some basic examples on what mole is, and then how we can solve it using Avogadro's number and then capital N, which is what? The number of entities. So we have been asked to do what? Calculate the number of what? I oxygen molecules, then I oxygen atoms in 0.5 mole oxygen gas. We have been given the L or the Avogadro's number to be what? 6.023 times 10 raised to the power 23. Alright, so let's go ahead and write down our solution. First of all, we have been asked to find what? Calculate the number of moles the number of what? Oxygen molecules. So we know the N, capital N is equal to what? Small n multiplied by L. And then we know N, the capital N is what? The number. So whenever we hear number, we know it's what? The capital N. If we hear amount of substance, we know it's what? Small n. So let's know that. So number is what? Capital N. Number of something is what? The capital N. The amount is the n, small n that we have over here. So the question is saying calculate the number. So we are using what? The capital N, which is the number of what? Oxygen molecules. Now an oxygen molecule is this O2. So in this case, and we are being given the mole to be what? 0.5. So we multiply 0.5 by the Avogadro's number, which is what? 6.023 times 10 to the power 23. So our number of what? Oxygen molecules, or O2 over here, if we punch this into the calculator, is what? 3.01 times 10 to the power 23 molecules of what? Oxygen gas. Now let's look at the second aspect. The second aspect is telling us to find what? Oxygen atoms, not molecule but atoms. Now oxygen molecule is what? 2 oxygen atoms. So oxygen molecule contains what? 2 oxygen atoms. So which means the mole of what? The oxygen molecule here is what? 0.5. But for the oxygen atom itself, it will be twice that mole, which is what? 0.5 multiplied by 2, which is equal to what? 1. So for oxygen atoms, it will be what? 1 mole of the oxygen atom. So if that is the case, it means our N, his number, is equal to N times L, and then our N is what? Our mole is still is now 1, because we are using because we are finding atoms, so it's twice the oxygen atom. So it's 1 multiplied by what? 2 is 1, sorry, 1 multiplied by what? 6.02 times 10 to the power 23. So this is still the same amount of what? Entity. So it's 0.23 times 10 to the power 23 what? Atoms of oxygen. Okay, so this is just the first example. Let's look at another example. So what is I? The mass of 0.8 mole of sodium carbonate. I, the amount of substance, or the mole of 5 grams of calcium carbonate, given that the relative atomic mass of sodium is 23, carbon is 12, oxygen is 16, and then calcium is 40. So let's write down our solution. And then I, what is the mass? So we have been asked to find the mass. We do not know, but we know the mole, N, is what? 0.8 over here, and then we are being given the compound to be what? Sodium carbonate. All right, so we know mole is what? Mass over molar mass. Okay, so which means if you want to find the mass over here, mass is what? Mass is what? Mole times molar mass. But we do not know the molar mass of what? The sodium carbonate that we have. So we need to calculate the molar mass of sodium carbonate, which is equal to what? We have 2 atoms of what? Sodium. So we have 2 Na plus 1 carbon plus 3 atoms of what? Oxygen. Now the relative atomic mass for sodium is 23, so plus carbon is 12 plus 3 into bracket, oxygen is what? 16. So if we compute this into the calculator, we are going to get 106 gram per mole. Gram per mole is the unit of what? Molar mass of a compound. So from here we can go on ahead and say our mass is equal to what? Our mole, which is what? 0.8 multiplied by our molar mass, which is what? 106. So our mass in this case is what? 84.8 grams. So this concludes the first aspect of the question. So the second aspect of the question is saying amount of substance. So we are to find the mole, given that we have the mass is what? 5 grams, and then our compound is what? Calcium carbonate. So like we did before, we have to find the mole, and then we know mole is what? Mass over molar mass. The same way, we do not have molar mass, so we need to calculate the molar mass of what? Calcium carbonate. So let's do that. So molar mass of calcium carbonate is equal to what? The calcium plus carbon plus what? 3 moles of what? Oxygen. So we have our calcium is 40 plus carbon is 12 plus 3 into bracket 16 for the oxygen. So it means our molar mass over here, if we input this into the calculator, is what? 100 gram per mole for our molar mass. So it means our mole, or the amount of substance, is what? 5 grams over what? 100 gram per mole. So our mole over here is what? 0.05 moles. Alright, let's have a look at another example. So we are to calculate I, the number of atoms present, the number of what? Atoms, number. So we are to, the number over here means what? Capital N. So number of atoms present in what? 1.5 mole, our small n, of sodium, II. The number of chloride ions present in what? 65 grams of calcium chloride. So let's start. The first one is saying what? The number of atoms present in 0. So our mole is what? 1.5 mole, and then our element is what? Sodium, which has the relative atomic mass of what? 23. So let's look at that. To find the number of atoms present, capital N is equal to small n times L. So we have our small n is 1.5 times Avogadro's number, which is 6.023 times 10 raised to the power what? 23. So it means our capital N is what? Or the amount, or the number, sorry. Number of what? Atoms present is 9.035 times 10 raised to the power what? 23 atoms of what? Sodium. So II, we have to find what? The number of chloride ions. So chloride ions, the number of chloride ions. So capital N of what? Chloride ions, we do not know, but we have the mass to be what? 65 grams, and then the compound we are using is what? Calcium chloride. So first of all, we know that what? Capital N is what? Small n times L, but we do not know the small n. So we know small n is what? Mass over molar mass. So we need to find the molar mass of what? Calcium chloride. So this is what? 40 plus carbon, which is 12, plus what? Sorry, this is 40 plus what? Twice chlorine, which is what? 35.5. So this will give us what? 111 gram per mole as our molar mass. So from there we can say what? Our mole is what? 65, which is the mass, divided by the molar mass, and then our mole is equal to what? 0.586 moles of what? Calcium chloride. So this is the mole of what? Calcium chloride itself. But the question is telling us to find the what? The number of what? Chloride ions. So it means we need to find the mole of what? The chlorine ions. So we write calcium chloride, and then we get calcium plus 2 chlorine ions, calcium 2 plus. Okay, so if this is the mole of the calcium chloride, 0.586, it means the mole over here will also be 0.586, and then the chlorine ions will be what? Twice 0.586. So the mole of what? The chloride ions, the mole of what? Chloride ions is equal to what? 1.17 moles. If this is the case, it means what? Our capital N, or the number of chloride ions, is now what? The mole, which is 1.17, times the Avogadro's number, which is what? 6.023, times 10 raised to the power what? 23. And then this will give us what? 7.047 times 10 raised to the power what? 23 chloride what? Ions. So this is how we solve basic problems on mole concept. Hello and welcome to my science tutorials. In today's video, we are going to be looking at mole concept 2, where we will dive into what? Concentration. What is a solution? A solution is a homogeneous mixture of a solute and a solvent. A solute is a substance that is soluble in a solvent, and a solvent is that substance that dissolves the solute, and it is usually a liquid. Now, the quantity of solute in a unit quantity of solution is called the concentration of the solute. Concentration can be expressed in four main ways. We have I, the amount concentration, which we normally just call concentration, II. We have the mass concentration, III. We have the molar concentration, and then lastly, we have the mole fraction. Now, for the purpose of these tutorials, we are going to be looking at just amount concentration and mass concentration. So let's begin. What is amount concentration? Amount concentration, this is the amount of substance dissolved in 1 dm cube on 1 liter of a solution. It has the SI unit of what? Mole per dm cube. Mole per dm cube, or mole per liter, or molar. Remember, I said amount concentration is the amount of substance dissolved in what? 1 dm cube, or what? 1 liter of solution. Now, amount concentration is given to us by capital C is equal to what? N over what? V, where N is what? The mole. V is the volume. This is where we get the definition what? Amount concentration is the amount of substance dissolved, which is what? The mole. The mole here is the amount of substance dissolved in 1 liter of a solution, and then the liter of solution is the volume. All right. Now from here, we know mole can be written as what? Mass over molar mass. So if we substitute this into this as our equation 1, we get our concentration to be what? Or amount concentration to be mass over molar mass multiplied by volume. So this is very important in calculating concentration. Let's go ahead. What is mass concentration? Mass concentration, II, mass concentration. Mass concentration, this is the mass of a substance dissolved in 1 dm cube of a solution. It has the unit gram per dm cube or gram per liter. Now, mass concentration is given to us by the symbol rho is equal to mass of a substance dissolved in what? A volume of solution. Now, from here, we know that what? From here, we know mole is mass over molar mass. So from here, if we make mass the subject, we get our mass, to be what? Mole multiplied by molar mass. Let's make this equation 4, because this is equation 3. Now, if we substitute equation 4 into this, or in place of this, we get what? Mass concentration to be what? Mole times molar mass divided by volume. Now, we know mole over volume. What we have over here, let me use another color. Mole over volume is what we have as what? The normal concentration. So it implies that our mass concentration is equal to what? The amount concentration times molar mass. Equation 5. So these equations that we've seen so far are very, very important in calculating or solving problems involving concentration. First of all, we say what? Concentration is what? Mole over volume, or concentration is what? mass over molar mass multiplied by volume. We also said mass concentration is what? Mass over volume, or mass concentration is equal to what? Amount concentration times or multiplied by molar mass. We also know that mole is what? Mass over molar mass. Alright, with these few formulas or deductions that we have so far, let's go ahead and solve some questions. Example number 1. Calculate I, the concentration of solution prepared by dissolving 5 grams of sodium chloride to make 500 cm³ of solution. II, the amount of sodium hydroxide in 1 dm³ of a solution of concentration 0.1 mole per dm³, given that the relative atomic mass of sodium is 23, chlorine is 35.5, oxygen is 16, and hydrogen is 1. So let's write our solution. So I, the concentration of solution prepared by dissolving 5 grams. So our mass is what? 5 grams of what? Sodium chloride. Okay, so we have our volume to be what? 500 cm³, which when we convert into dm³ will be what? 0.5 dm³, because 1000 cm³ makes 1 dm³. Alright, so we need what? We need the molar mass of the sodium chloride that we have. So the molar mass of sodium chloride is what? Sodium plus what? Chlorine, which is what? 23 plus 35.5, and this is equivalent to 58.5 gram per mole. Now that we have our mass, volume, and then molar mass, we can calculate our concentration, which is what? Mass over molar mass multiplied by volume, and this is equal to our mass is 5 grams divided by our molar mass is 58.5 multiplied by the volume, which is 0.5. So this is equal to 0.171 mole per dm³. So our concentration for the I is 0.171 mole per dm³. Let's have a look at the second aspect. The amount of sodium hydroxide in 1 dm³. So our volume is what? 1 dm³ of solution of concentration. So our concentration is 0.1 mole per dm³. Alright, and we have to calculate the amount of sodium hydroxide. Amount of sodium hydroxide means we need to find the mole or N. But we know concentration is mole over volume. Now that we have the concentration, we have the volume. Our mole is simply the concentration multiplied by the volume. So our mole is equal to 0.1 multiplied by the volume, which is 1. So the mole in this example is 0.1 mole. Alright, let's have a look at another example. I, what volume of 0.30 molar sulfuric acid or H2SO4 would contain 1.35 grams of sulfuric acid? II, an amount of 0.25 grams of aspirin with the formula C9H8O4 is contained in 100 cm³ of a solution. How many moles and how many molecules of aspirin are in 1 dm³ of the solution, given that the relative atomic mass of hydrogen is 1, carbon is 12, sulfur is 32, oxygen is 13, and then Avogadro's number is 6.023 multiplied by 10 raised to the power 23. So let's write our solution. I, what volume of 0.30 molar? So our concentration is 0.30 molar would contain a mass of what? 1.35 grams. And then the volume is what we don't know. So we need to get the molar mass of what? H2SO4. And this is equal to hydrogen, twice hydrogen, plus sulfur, S, plus 4 times oxygen. This is 2 into bracket 1 plus 32 plus 4 into bracket 16. The sum of all these numbers is equal to 98 gram per mole. Okay, now we need to find the volume, and we know concentration is equal to mass over molar mass multiplied by volume. So if we make volume the subject, we are going to get, we cross multiply, we have concentration multiplied by molar mass multiplied by volume is equal to mass. So we divide by what? Concentration and molar mass. Concentration and molar mass. So we get our volume to be mass divided by concentration multiplied by what? The molar mass. So our volume is the mass, which is what? 1.35 grams, divided by the concentration, which is 0.30, multiplied by what? The molar mass, which is what? 98. So our volume in this example is 0.046 what? dm cube, which is equivalent to what? 46 cm cube. All right, let's look at the II aspect of this example. II, an amount of what? 0.25 grams. So our mass is what? 0.25 grams of aspirin. So the molar mass of aspirin, C9H8O4, is this, 8 multiplied by hydrogen, and then 4 multiplied by oxygen. This is 9 into bracket 12 plus 8 into bracket 1 plus 4 into bracket 16. This is equal to 180 gram per mole. So it contained what? 100 cm cube of solution. So our volume is what? 100 cm cube, which is equivalent to what? 0.1 dm cube. So we have been told to find the how many moles and how many molecules of aspirin are in 1 dm cube of solution. All right, so first things first. So first of all, we need to get the mole of the aspirin that is present in what? 100 cm cube. So we can get that by using the formula mole is equal to mass over molar mass. So which means our mole is equal to 0.25 divided by 180, and this is equal to 0.001389 moles. All right, now that we have the moles, let's go ahead and see what the second aspect of the question is telling us to find. How many moles and how many molecules of aspirin are there in what? 1 dm cube. So our volume is what? 1 dm cube of the solution. Now, if we already find the mole in what? 100 cm cube, and it's equivalent to what? This, what we have over here. So if the mole in what? 0.1 dm cube, okay, is equivalent to what? 0.001389. Then the mole in 1 dm cube will be equivalent to what? Let's use the symbol n. So if we cross multiply, we have 0.1 n is equivalent to what? 0.001389. So our mole will be what? 0.001389 divided by 0.1, and this is equal to 0.01389 moles. Alright, so it means the mole in 1 dm cube we now have, and then we have the volume, so we can now go ahead and calculate the second aspect, that is what? How many molecules of aspirin that we have. Now, how many means the number, so the number, which is capital N, is equal to what? The mole multiplied by what? The Avogadro's number. So the capital N is equal to 0.01389 multiplied by what? 6.023 times 10 raised to the power 23. So our capital N, or what? The molecules of aspirin present in this example is 8.37 times 10 raised to the power 21 molecules of aspirin. So thank you so much for watching. If you are new around here, kindly consider subscribing so that you don't miss any of our latest tutorials. Thanks for watching once again, and I'll see you in the next video. Bye bye.